Hello students, welcome at Educare. This is Bihani and we are continuing our topic called valence bond theory part 2. In previous part we have seen how a covalent bond is formed by the overlapping of atomic orbitals, and there are few conditions for overlapping. That is, every orbital cannot take part in bond formation. Only those orbitals containing one unpaired electron can take part in overlapping, means ultimately in the bond formation. Then orbitals containing paired electrons, that is a pair of electron, does not take part, or they do not take part in the bond formation. Means if it is the such orbital in the block diagram we show like this orbital will not take part in bond formation in any case. We have seen already s orbital capacity 2 and it is of only one type. P orbital, it's having total capacity 6, but there are 3 p orbitals, that is 3 into 2 6. So 3 p orbitals, but that contain 2 electrons each. D orbital total capacity 10, there are 5 d orbitals with 2 electrons capacity each. So that 2 is underlined every time. And F orbital has 14 electron capacity, there are 7 F orbitals, each has 2 electrons, the total 14. But more important is this underlined 2, that is every s orbital, p orbital, d orbital as well as f orbital, they have only 2 electrons in the capacity. Actually, bond formation is the pairing of bond. Unpaired electron get paired with other atoms orbital. That other atoms orbital at the time of chemical combination, that should have the opposite spin for the overlap purpose. Now, like we know that we have seen already, two hydrogen atoms overlap, I mean their orbitals SS overlap like this, one is orbital, and that is the H2 molecule form. Now here it was assumed that these 2 electrons with opposite spin, something like this. Okay then, it is required to know the equilibrium distance between two atoms. What is that equilibrium distance called? When two atoms approach each other for the formation of covalent bond, now there is change in energy as well as the attractive and repulsive forces between their electrons as well as nuclei that come into existence. Attractive forces increase, repulsive forces minimize or that get reduced to some extent, and the minimum energy is required for the formation of covalent bond. When a covalent bond is formed by such overlapping, there is minimum energy of the system. Two individual atoms, they have the more energy when they combine, when that orbitals overlap, energy is released. Energy is released means their energy decreases, and at certain minimum energy, that is the least energy, where there is distance called equilibrium distance, like these two hydrogen atoms here in the 1s overlap that get a covalent bond form. Then it is not necessary to know about the d and f orbitals. For the moment, s and p orbitals sufficient to know, and only for the formation of covalent bond, this valence bond theory is least energies for the most energy. In the science, in the physics, chemistry, there is a rule for the maximum stability, it required minimum energy. And the equilibrium distance, then it is called as afterwards bond length. And the energy released to form that bond is called as bond energy, or it is also termed as bond enthalpy. More extent of overlapping gives stronger bond means its bond enthalpy or bond energy is also more. Now, it is also necessary to know the paired electrons, if are present there in the orbital, they cannot form the bond. Means in this situation, this pair of electron will not able to form bond. Now, we take the example of such element which has the unpaired electron, and that is suppose fluorine. Fluorine has atomic number 9, its configuration 27, and this 1s2, 2s2, 2p5. This 2p5 further 2px2, 2py2, 2pz1. Now this 2pz1 underlined is containing only one electron, that is unpaired electron, means whenever fluorine will take part in bond formation, that is covalent bond, its 2pz orbital, that 2pz orbital dumbbell shaped, something like this, and that contains such unpaired electron. If you can show the other lobes also there, suppose it is 2pz, this 2px, 2py, like that. So this orbital will take part in bond formation. For example, this is formation of HF. HF. So this hydrogen will have this opposite spin electron. This is the 2pz of fluorine, and that is the HF molecule. Here it is the overlap region. And now it is necessary to know all covalent bond, not only H2, not only F2, not only HF, but all covalent bonds, they are formed by such kind of overlapping of atomic orbitals. So that is the overlapping is important. Number of unpaired electrons gives number of covalent bond. By the overlapping, that formation of covalent bond means ultimately it is valency, and this minimum energy, maximum stability, equilibrium distance called bond length, all these are very important in understanding valence bond theory. There is a octet rule and limitations of octet rule there. Like this valence bond theory, its limitations are also there, and that's why it is needed the concept of hybridization that we'll take in the next session. Okay, thanks. As we have come to an end, like this video, comment which concept you want to see next, share this video with your friends, subscribe to our channel, and don't forget to click on that notification bell icon.